just wait for... Are we good to go? Okay, so it gives me great pleasure to introduce Noel Matthews, who's G8 GTZ. And it says here that he's always been interested in microwave bands. He's president of BATC, of which many of us know him from. Interestingly, he's never operated on the HF bands. So I think, Don, you see there's a bit of a crossover here, maybe possible. Okay. I'm really looking forward to this talk. So it's going to be about adventures in 122 gigahertz. Okay, that's not a mistake there, gigahertz. And he's going to talk about the challenges and fun of operating on 122 gigahertz. And particularly with these new VK3 CV transverter boards, which have made it possible. So some of us have got them on our shelves, so hopefully this will provoke us into getting them going. And he's going to talk about how him and Dave, G1 EHF, have used these boards to go from having a first QSO over a couple of kilometers to breaking the UK record at 36.5 kilometers. So look forward to hearing what Noel's got to say. So over to you, Noel.
Thank you very much. And yes, really this is just to impart what I've learned over the last couple of years. I'm really pleased. I know at least 2 people in the audience have also bought the VK3CV units. So I deliberately put on here a lot of acknowledgements to some guys, G1 EHF, G8 ACE, G8 AJN, G0 FTZ, G6 CAM, K6ML. And the 122 project group, because a lot of what I'm presenting today, I've gleaned and learnt from those guys. And really, all I want to do today is impart this knowledge to you to hopefully inspire you to take that box off the shelf and actually get it on air. So, where is 122 gigs? I thought I'd start there first. These are not the ITU terminologies of VHF, UHF, EHF, and whatever, but this is how we, in the amateur world, tend to look at it. VHF, you all know, UHF is mainly 70 SEMS, and then it kind of breaks up into the lower microwave bands, anything between 1.2, 2.3, 3.4, and 5.7 are really considered to be sort of the lower microwave bands, and the higher bands are 10 gigs, 24, 47, 76 gigs. And believe it or not, you still keep counting after that, because there's then 122, 134, 241 and above. And so what we're talking about today is right up here at 122 gigahertz. And having said all about those bands, I think it's fair to say that, you know, there's a couple of bands that have always stood out as being easier. 23 SEMS always been a stepping stone. If somebody comes along and says, "Oh, I fancy doing some microwaves," we tend to say, "Well, try 23 SEMS first, because that's easier, and that will give you a flavour of what, you know, the excitement of working on microwave bands." And there's lots of activity, and there's lots of designs and some surplus, so it's relatively easy. 13 SEMS is not so easy. It's become a bit easier now. QO100, the satellite is there, and there are UMTS spare amplifiers and stuff. So 2.3 is a little bit easier. 3.4, you're getting into the really esoteric ground here. There was surplus around from the wireless broadband systems called Ionica. Apart from that, that's a challenging band. 5.7, very little surplus, although there were some 15-watt amplifiers from Ferranti, but nothing else available. So they were the harder bands, if you like. 10 gigs always seemed to be the next step. 10 gigs always seemed to be the place where people went to get a real taste. And lots of designs, lots of surplus from gun diodes upwards. And today, even the TV LMB, the receiver electronics on the dishes, give us the ability to build receivers which have got pretty good performance relatively cheaply. 24, and then when you go from 10 gigs up, 24 gigs becomes hard. Until relatively recently, there's been some very interesting units on eBay called Wavelab transverters, and that's literally put an LO in, put some volts on it, and if you've got a Pluto that you can operate up at 2.3 gigs as the IF, very simple to get going. And then it definitely gets harder, 47 and 76 gigahertz, and above 100 gigahertz, well, that was just out of this world. And until 2019. And what happened in 2019, in the autumn edition of Jubus, there was a design by VK3CV, and it was entitled 122 gigahertz for all, and that's exactly what it was. And what that article described was a single PCB that Andrew, VK3CV, had designed, and it's based around a car collision radar system chip built by a company called Silicon Radar. And the chip, very small, I think it's about 4 mil big. It sits in the middle of the board inside those 4 2 mil holes, M2 holes. And that chip, believe it or not, is a 122 gig system on a brick. That's it. All of the rest is just periphery stuff to get it going. It's the receiver has got I&Q output, so you can use any of the modern SDRs to receive it, and you can do all modes receive. The one limiting factor with it is that the transmit is FM only. But it will do, of course, do CW, and Hellscriber has come back to a 4 because Hellscriber, which is a RTT white type mode, but it's an on-off mode. So it will actually work on these units, and is actually a relatively low signal mode. And there has been some use of WSJT modes using a special. If you adjust the FM modulation carefully enough, you can get it with suppressed carrier FM to run WSJT. Very simple to get on air, and it outperforms the units people were using, which were basically mixers and multiplier diodes. But the disadvantage is no SSB. So what it looks like in the Silicon Radar chip inside the dotted line, you've got on the transmit side, you've got an external 1.9 gig PLL, and that's a good old 4153 analog devices synthesizer. It's got a 10 megahertz reference, which is really good because we can in fact lock them to GPS or a high stability 10 meg source. So that's taken away one of the issues when operating microwave. The two issues when operating microwave are, where am I and where am I pointing? They're the two big difficult things to get over. And actually, even though you're on 122 gigahertz, you can pretty much guarantee your frequency, plus or minus, not very much. So the 1.9 gig PLL can also be modulated, and that's how you get the FM into the system, by modulating at 1.9 gigahertz. That goes into a power amplifier which is on the chip, and the antenna is on the chip. There's a half-wave dipole on the antenna. On receive, another half-wave dipole into a low noise amplifier and mixers, and that brings out the I&Q. So as I said earlier, that can go into just a 144 meg IF. So because it's FM, you could in fact use a handy talkie, but actually using something like SDR Sharp with a waterfall on it is really useful. So that's the chip in itself. Actual performance, I think that's being a bit optimistic. I think it's probably nearer minus 10 dBm, so not a lot of power output. The receiver noise figure is round about 12 dB, which sounds a lot, but actually for 122 gigahertz is pretty good. The challenge, one of the challenges was, of course, if those antennas are embedded in the chip, how do you then couple out to the outside world? And luckily, Andrew has solved that. So to actually get it going, it's actually not that difficult. 12-volt power in, GPS in, or TCXO, INQ output. Then you've got PTT and key, Morse key, CW, and a mic. And it uses an electret mic, so any old PC type mic will do. And that's literally it. There is 2 ways to program it. You can go on there, or you can go on, there's an RS-232 port on it. And there is actually channel selection. The way the board is built, you probably saw on the previous slide, there's a multi-way selector switch on it, and you can program a number of channels. But in practice, when we're using it in the UK, we only use 2 channels. So an A-B switch is what most of us have gone for. So that's basically the equipment. The board itself is relatively simple, and you can hear signals across the shack using that. But when you start to then look at 122, you realise perhaps that's not quite all. Whoops. First of all paths are line of sight. Don't even think of it not being line of sight, going around the corners or through trees. And trees and buildings cause significant loss. And when you're doing path plots, you have to use a K factor equals 1, which is basically optical. So if the path is optical, it's likely that 122 will go. If there's anything else in the way, probably not. Beam widths, dish beam widths, because we've got very high gain, have become very narrow. So tripod stability and dish alignment initially is a challenge. I've already talked about frequency stability. We've got round that. The free space loss, which is what this chart shows, actually for a 100K path, if you look at it, 10 gigs got a minus 152. 123 gigs is actually 174. So it's only about 20 dB worse than 10 gigs. And you've got more dish gain, so it shouldn't be too much of a challenge. But actually, the problem is atmospheric loss becomes a major problem at 122 gigs, which you're not seeing at 10 gigs at all. You see it a little bit at 24, but by the time you get to 122, atmospheric loss is a real problem. In fact, the ITU wrote a paper on it, and all of the data in the next slide is taken from the ITU charts. So, above about 20 gigahertz, water vapor becomes an issue, and that's fine for people who live in Texas or Australia. But in the UK, water vapor is certainly something we have. And that can add more than 1 dB per kilometre, which if you're trying to do a 20K path, well, that's 20 dB more attenuation over and above the free space loss. So on a 40K path, which is the kind of paths we're getting to now, you know, your free space loss is 166, but you've got to add 30 dB to that. So that makes it really challenging. There are also, oxygen has resonance. That has resonance at 60 and 119 gigahertz, and is shown, this chart wasn't particularly clear, but shown on the blue line, which peaks. And so actually using the top end of 122 is better than the bottom end to get away from that oxygen peak. The other thing the textbooks point out, that of course higher elevations are good because you've got less oxygen at higher elevations. Well, That doesn't apply to the UK either, does it? You know, particularly the southern part of the UK, you don't have many hills where you need an oxygen mask. So, you know, whilst it's a fact that you can get rid of oxygen loss by going higher, it doesn't really apply to where we are. But the one thing you've really got to take account of then is the humidity, and we learnt some lessons which probably everybody else knew, but looking at charts and saying the relative humidity is low is not actually a good measure, because on a hot day, you can a low relative humidity, there's still a lot of water vapor in the air. So the measure that we use is dew point, which takes into account relative humidity and temperature, and it's the point where air temperature at which saturation occurs. And so you look for a low dew point, because that then takes humidity and temperature into account. So it gives you a measure of how much water is held in the air. So that's all important. So in the UK, line of sight, high ground is good, but don't just go for its high. It's got to be, the plateau effect is no good. You need to be on the edge of a cliff, relatively speaking. And you need to choose your day carefully to minimise these losses. An average UK grey day, probably not quite today, but you know, one of those days when in November when it's just cloudy and not much else is going on, your dew point is up at about +9. Whereas in somewhere like Texas, you know, it's 19 degrees centigrade, but a dew point of -6. So, you know, so you have to watch the weather forecast and pressure forecast if you're trying to plan to go out to do 122. Or G8AJN has developed a box which will do this for you, and it's based on an Arduino, and it gives real-time measurement of location, day, time, and also the pressure and temperature. And from that, if you type in the other QRA, the other end QRA, it will then give you propagations based upon the ITU model. And it logs it to an SD card, because that's quite useful. So when you get home, you can look at what the parameters were on the path that you worked, which is quite interesting to see what you can do next. So the details are on, I guess the UK Microwave site has got a link to that, or if you just Google G8AGN AGN weatherbox. So having worked out that 122 has got its own interesting foibles, we then need to talk about putting antennas onto this equipment. And actually how the antenna works is the 4 M2 holes around the chip have been put there to enable you to place, you're not going to see this on the web, but so that is a coupler that Andrew designed, and I'll pass this around, and it results in a chaparral type feed, and this gives you an idea of the sort of waveguide we're talking about. And so that goes on top of the chip, and it's stepped chambers inside, and so couples into the feed. Similarly, the horn you see lying there, that's a picture of my unit, but it's top off or here. That horn is screwed through those holes and has got a similar coupling arrangement in the back end. I'd appreciate that back at the end. So having coupled it into external antennas, then the world is to play for, because the horns have got about, I think it's over 20 dB. So this little horn here has got over 20 dB of gain, the one shown there. And you can work paths of up to about 5K in the UK, 2 horns back to back, can work up to about 5K, or you can then use that horn, as I've been doing, to then feed a dish. So you can use the antennas, the horn antennas, you can use dish antennas, or you can use lens antennas. Unfortunately, you don't find many 122 gigahertz dishes on eBay. But you can have a lot of fun playing. Now, here's an interesting fact, that a 60 centimeter satellite dish has probably got the same gain as the 32 meter antenna at Goonhilly on 2.3 gigs. Good quality satellite dishes, people have had a lot of success. Basically, if the reflector is fairly true in mechanical design, they work quite well. Mesh dishes don't work, and obvious reasons. If we've just said that's the waveguide for 122, you'd have to have a pretty small mesh dish to for it not to fall through. Optical dishes, yes, although I did wasted a lot of time playing with an optical dish that I'll show in a minute. So there's lots of fun to be had trying to work out what will work best. And just to give you an idea of if you can tame a dish on 122 gigahertz, you can get some real gain. A 2-foot or a 60 centimeter dish will give you about 56 dBi, but with a beam width of 0.25. If you go to a 4-foot, you'd end up with a beam width of 0.13, which is the reason why nobody uses 4-foot dishes. So I've got some pictures of dishes in a moment, but once you start to play with antennas, you then need to, you can't, unless you've got a buddy who lives around the corner, you really need to be able to generate a signal to be able to test what you're doing. So unless you bought 2 of these, which stupidly I didn't, I only bought 1, then you have to think of some way of building a source. And it's actually surprisingly easy to generate a low-level signal at 122 gigahertz. If you drive a microwave diode at 11 gigs, it will generate low-level signals on 122 gigs. And so this is a diode on the end of a piece of semi-rigid in the base of a WD-40 can. And that works quite well. This receiver can hear that at well over 10 meters away. And so what I did was, it was non-scientific, it's just comparative tests between the different antennas. And the good thing is you can always come back and use this horn as the reference. So you haven't got absolute measurement, but you've got a reference back to that. Oh, this one seems to be 13 dB better, this one is 16 dB better. And actually the results I got, I started in the garden. I must admit I ended up doing it in the front room, which surprised me that it still worked in the front room. We got a front room with a conservatory, so I had about 25 feet of range. And the results I got through doing that were actually reflected in what we did when we went out in the field. So, yeah. So I can pass that around if anybody's interested. The thing to look for is the tiny little diode in the end. So dishes, all sorts of ways of doing this. The major issue with prime dishes is blockage. Some people have managed to put or tried putting the whole transverter in the feed point of a, I think that looks like a 20 gig dish. This was G8AGN using a TV, a 40 centimeter TV dish Notice he's mounted it on his side because of this theory of the beam width when you do that is wider. This was one of mine. That's that transverter feeding a small 30 centimeter dish. Here's a design. This is actually the dish I used in the end, and Gareth G4XAT. So the transverter would sit at the back, fire through the whole of the dish, and this is a sub-reflector with some 3D printed sub-reflectors, and also Dr. Pepper and Coke cans, and I've tried all sorts of things. And so experimenting with these, they're typically the type of sub-reflector you can use on a prime dish. And Gareth made this adjustable position, which was very useful. And I think this was Andrew, VK3CV, and he's used the tiny chaparral feed that I passed around to feed this offset. So lots of that's real radio, you know, that's real amateur radio. We got excited when there's a company called Edmunds who do optical stuff, and they had a nice 18-inch dish. We got very excited, and they were running 20% off, so we bought a couple, and unfortunately I forgot to measure it. We did measure it, but the F over D is too deep. We just couldn't feed it properly. I tried for quite some time to feed it. Here it is. You'll recognise that. So it's stuck on the front. I tried mounting the PCB in front of it. Interesting, guy in France, can't remember his call sign, he did the same. So this is the Edmunds optical dish there. He mounted his transverter at the focal point and had some success with it. But I found I got too much blockage when I did that. And overall, it just wasn't as successful as I thought it would be, which was unfortunate. The other thing is lenses. That's a picture that Barry G8AGN took. This type of thing. Fresnel lens printed in super duper, not sure quite what it is, but it's some form of low loss. And I mean, I bought this one the other week, and it's calibrated for 76 gigahertz. Believe it or not, that's got 34 dB of gain at 76 gigahertz. So a lot of potential to try those. I'll be trying that one during the coming season to see what that does. So you know, it's all things to try and things to experiment with. I think perhaps the most successful thing we did was using lower frequency dishes, 47 and 50 gig dishes. I had a nearer dish, this one here, which has got a Cassegrain sub-reflector feed in there. Dave G1EHF has only used this dish, so that's an NEC Passolink dish, sub-reflector, and you can see just poking through it is the horn of his VK3CV. And that worked pretty well. I took off the 47 gig coupler and discovered it had got circular waveguide, which I then fed. I think I used the chaparral feed to feed it, and that worked really well. Unfortunately, stupidly, I went and built a 47 gig system over the winter 2 years ago, and so I couldn't use it on 122 gigs. So just one more slide on equipment, then we'll talk about what we did. There are several improvements you can make to the VK3CV. We've talked about frequency stability. I added the TCXO on the back here. I didn't go for GPS, and that made a big difference. In a moment, there's a video of my non-modified transverter. It moves around a little. INQ filtering, currently as they're produced, there is no INQ filtering, so you're hearing both the I and the Q. Theoretically, there is a 3 to 4 dB improvement from using a combiner, and somebody's done a PCB which you can add. We tried it; it didn't seem to make that much difference, but some people are saying they're seeing a couple of dB improvement. And then obviously data modes, CW and HellScriber, as I say, can be done. Barry AGN has done at the top there an Arduino with a PS2 keyboard to run HellScriber. Other people have experimented using WSJT. If you get the modulation index correct, it will in fact reduce the carrier, so you end up with an AM reduced carrier system, and people have had WSJT QSOs on 122 gigahertz using this type of equipment. And some people have also experimented with SSTV, but of course SSTV is purely FM tones, so that doesn't buy you anything. So they're the types of things that people are experimenting with. So what did we do? Well, first QSO was a 24/47 76 gig weekend, and we did 2 kilometers. 1.1 kilometers, sorry. Line of sight path. In fact, so line of sight that on this top picture you can see the path. That was my equipment at my end. This is 24 gigs, and there's the VK3CV just sitting there. And that really gave us the confidence to then go on and do more stuff. And later, about a week later, we had our first real QSO over 2 kilometers. And there's a few videos coming up, Dom. So I'm going to find... Right.
It must have a lot of gain, mustn't it? And that sort of, it follows, I guess.
So that's Dave. I'm just doing a quick video.
Okay, T8TTZ portable, G1 EHF portable, in Italy Oscar 91 Kilo Hotel.
He was on the ridge by the greenfield.
Italy Oscar 91 Kilo Hotel 10 Charlie Delta. My microphone sounds a little bit poppy, actually, doesn't it? And there's slight signs of feedback from the...
Yeah, once it's on frequency, it doesn't sound too bad.
Yeah, basically I've got 5 kc steps on my...
So that was our first real going out and trying to find each other and, beginning to learn. We then...
It must have a lot of gain, mustn't it?
Shush. We then ventured out, and these are all local paths. What you need to do is look carefully around, and actually you'll find in most places there are 10-kilometer paths, clear line of sight paths. If you just look when you're driving around, I can see through that hedge over there. 10k paths aren't that fine. What we found is there's one very good 12k path that we use regularly, but then after that, a 20k path was really hard to find. So we went out and did the 20k paths. Yeah, Roger, Dave. As I say, you're also 5x3 in also quite scratchy FM, and I'm just doing a quick video. So if I zoom in where you are, you're not there, you're over there. So that's 12k. to the horizon there. That's 12K.
Okay, good.
So we did that. Pardon me. We did that path a number of times and experimented. And then we realized, that's right, then on the microwave reflector, some horrible little GMs popped up and said, oh, we've just worked GM to G on 122 gigahertz. And we looked at what they'd done, and basically they worked across the road. So we thought, right, and realized that G to GW hadn't been done at 122 gigs either. So we went off to the Severn Bridge, and we had a bit of difficulty because they closed the road on one of the places we were going to go. But in the end, we worked, I stayed this side, Dave and Neil, LDR, went to the other side. It was only a 2.4 kilometre path. It was actually through the 12th arch on the left. This is the M4 bridge, and they were here somewhere. And yeah, that was a fairly easy copy. I've since worked out that the dew point was, quite high, but it was only a short path. But of course, the challenge when you start doing those sorts of paths is what's going to happen over water with this stuff. That must have some impact. But yeah, so we did claim the first G to GW on 122 gigahertz. We then did find a 17K path. This was also another contest weekend. Dave was up at Walbury or Coombe Gibbet, and it was pretty misty and horrible. The top picture there shows the path, or shows him in the distance, and it was pretty horrible. And this was the occasion when I used my 47 gig dish, and that worked quite well.
Working, Peter.
So you can just see the hills in the distance. That was Coombe Gibbet stroke Walbury Hill in the far distance there. And that QSO is starting to show the problems for certain operators, because it's getting towards the end of the limit of FM voice. So we then had to start scratching our heads but no, we did actually do it on FM voice in the end, but that was 17K, but the weather wasn't great that day. But then we got bold and realised we were sitting on top of a 27K path we could do very easily, and we've done it a number of times since. And this is from Walbury Hill going south down towards Winchester. There's a path, 27K, but we got a bit more scientific about when we went out and did this one. All of the other contacts up until then really had been on the back of, because we were out doing other stuff. And we actually got scientific and worked out it was going to be nice and cold. And it was. There was ice on the ground, and the dew point was -3. It's a 26K line of sight path. And we then ran into another issue because the what's known as the Stockbridge site isn't actually on the horizon. It's lower than the horizon. And once you get that, it's very difficult to work out where the other guy is when you're looking 27K away. When guys are on the horizon, you can generally identify trees or bumps or whatever. But when they're down in the mud, it's very difficult to see where they are. And so that's when we ventured off into optical, and we started to use big 20-watt LED flat lights. And that really saved the day. Things were getting tough by now. So I've got a recording. I think this is a recording Dave took of my signal. And now this is where you'll notice that I wasn't running the high stability oscillator. So that was 27k. As I say, we're a bit more scientific on finding the day. But it actually took us a year to really then, I think we sort of rested on our laurels for a while. And we then decided earlier this year that we really ought to go out and do something else. And I'd identified a path that was 36k. It didn't look particularly special when you drive past it, but it's actually going east-west. Sort of, if anybody knows the area, along the A303 from the M3 out towards Andover and beyond. That's my setup. This is the Cassegrain feed on that. It's actually a Ubiquity 5.6 gig dish. That worked well. Weather conditions. Now, interestingly, we discovered that the path almost went straight over the top of the Chilbolton Weather Centre, weather station. So we could take the Chilbolton readings and know exactly what was going on. And it was actually a warm day compared to the days we'd been out previously. But the relative humidity was a lot lower. So it was warmer but lower. And so we came out at about minus 1.6. So again, below zero was important, and we think that's what made it happen. And we calculated later that the atmospheric loss was about 23 dB. So, it really is a killer. You've got to do this. If you want to do any path links at all, you've got to know what you're doing. Antenna alignment was an issue. That top picture is my bathroom mirror. Because I was in sunshine, because I was to the northwest of them. So I took my bathroom mirror, which is about this big, and could flash it. And that was a flash from the bathroom mirror that John captured at 36 kilometres. John and Dave went really well equipped. They were serious this time. So left to right, that's Dave's flat light. That is Dave 122 gigahertz. That, I think, was Dave's Finningley optical transceiver. That was John's flat light, and that's John's 24 gigs, and that's John's 122 gig. So there was quite a lot of equipment there. Once they'd found me, I could then see John's 20-watt LED flat light over that distance for most of the day. And we had really stable signals, optical and 122. Now, Dave was running the VK3CV. John wasn't. He was running a diode multiplier system, which was running about 5 milliwatts. And there was a significant difference in the signal strengths. And so that top picture, the signal on the far right is John's multiplier diode running probably about 5 milliwatts. And this signal here was Dave G1EHF on his VK3CV. And John was very keen on trying Hellschreiber. I think he has problems with CW as well as I do. And John was very keen to try Hellschreiber. And so this was John on Hellschreiber, and he was quite loud. As you can, pretty clear decodes. So that was 122 gigahertz Hellschreiber. Dave, who was much weaker, we did manage to copy it on Hellschreiber. And that was pretty tough going. It took a long time to get full decodes on that. In the end, I ended up. It's quite amusing, really. I ended up downloading a Morse code chart off the internet there and then, and I ended up flicking the channel switch in very slow CW. But he got it and he read it, and we got it across. And that currently is the UK record. We're amazed that John and Roger GHCUB, who's also got higher power equipment, haven't gone out and taken it away from us. But for the moment, we still hold the UK record. But other countries have it much easier in some ways. The world record is 157k on 134, and they had a one-way on 122. But it's a bit more challenging in some respects, but easier. They had a minus 16-degree dew point, which would make a lot of difference. The VK3 record, a couple of VKs in the desert have had a 52 kilometer QSO on them, using 35 mil, 350 mil offset dishes with a minus 5 dew point and probably quite a high temperature because they were in the desert. So yeah, we're not in the same ball, but we've had a lot of fun. So we can't beat those because we haven't got any mountains. Our dew point is generally too high. But really, what we've been doing is about what this. What we've done is really what the hobby's all about, as far as I'm concerned. It's getting out there and experiment, and do what we do best. So find out more. If you scan those QR codes, it will take you to a very good video of a lecture given by AGN. There's a two presentations from K6ML, and the 122 group IO group is the place to join if you're interested in doing this. So that's it.
Okay, so we've heard about the bottom of WD-40. We've heard about WD-40.
It probably fell.
So we've heard about WD-40 cams and the importance of mirrors. Has anybody got any questions?
And I'll repeat the questions.
Any questions? I suppose I've got a question.
Yep.
Like you, I managed to get one of the boards.
Yeah.
I'd like to have got another.
Yeah.
They sold out so quickly.
Yeah.
What's the status of the
I understand they're looking at doing. If you go to the group, you'll see there is talk of doing some more boards using a modified version of the chip, so it covers 134 gigs as well. So it's a dual band board. So that they are limited in supply really, but at some point there will be more boards coming up. So yeah, and they'll be dual band.
Any other questions? Okay, so can we thank once again Noel?